Okay, we're going to continue on with multiplying a whole number times a fraction. And on this one, we're really going to focus on modeling. So we're going to practice and go back and review what we just did or what we learned in the previous anchor chart. This one is going to go on page 70 on the left-hand side. So the first one went on the right-hand side like normal. This one's going to go on the left-hand side so we can have some models. So our problem for this first problem is going to be 2/9 times 3. And if we remember and we think about what we talked about, 2/9, we really say 2/9 of 3. And some things that I want us to really start paying attention to is, can our denominator go into our whole number evenly? Those are some questions that we want to start thinking about when we're talking about multiplying a whole number by a fraction. Well, it can't. 9 cannot go into 3 evenly. So we're going to do this one, and we're going to do repeated addition. We're just going to practice kind of doing the things that we learned. So 2/9 times 3 means that I've got 2/9 how many times? 3 times. So that means I have 2/9 plus 2/9 plus 2/9 3 times. 1, 2, 3. And I can add them. Well, when I add and subtract fractions, I totally add the denominators together. So I would have 27 as my denominator, right? Hopefully we said no. We never, golden rule of fractions, we do not add or subtract the denominator, ever, not in the history of time and for the rest of our lives. So we just pull it over. And then we add the numerator. 2 plus 2 plus 2, which is 2, 4, 6. Then we have an answer. We stop and we observe it. What do we observe about this? Well, if I know my multiples, I know that 3 can go in here evenly, both of them. I know that 3 can go into 6, and I know that 3 can go into 9. If I don't know that, what can I do? I can find the factors of 1 and 9. So we have, 6 and 9. We have 1, 2, 3, baby rainbow, 6. We have 1, 3, baby rainbow, 9. Well, 9 can't go in, 6 can't go in, 3 can, that's my greatest. We're going to divide this by 3, divide this by 3. We have 6 divided by 3 equals 2. We have 9 divided by 3 equals 3. We stop and we think. We observe this again. Well, if I know, and I remember the stuff I know about prime numbers, I know that 2 is a prime number, and 2 cannot go into 3 evenly. Therefore, this is our championship answer. So 2/9 of 3 equals 2/3. Does that make sense? If we multiply by a smaller fraction, is our answer going to be greater or smaller than 3? Well, it looks like it's going to be smaller. Okay, so now we're going to do another problem. And I want us to observe, like I talked about up here, I want us to start observing, does our denominator go into our whole number evenly? So the problem we're going to have is 1/4 times 12. Well, what do we observe about this problem? Remember, we're always trying to observe and think about what we see and what we know and what's being told to us here. Well, we know that 1/4, we're saying we're taking 1/4 of our 12. If we're taking a unit fraction of a whole number, is our answer going to be larger or smaller than our whole number? Scaling. I want us to think about what we know about scaling. Hopefully we're saying smaller, because we're not even taking a whole. When we multiply whole numbers, our numbers get bigger, but when we multiply by fractions, they usually get smaller. So we notice that we're taking 1/4 of 12. So our answer is going to be smaller than 12. Another thing I want us to pay attention to is, does 4 go into 12 evenly? Hopefully we're saying yes, because 4 times 3 equals 12. and that means that it goes in evenly. What this means though for us is that our answer is going to be a whole number, okay? So when our denominator goes into our whole number evenly, our answer will always be a whole number. I need you guys to plug that in and remember it. When our denominator goes into our whole number evenly, our answer will be a whole number. When our denominator does not go into our whole number evenly, our answer will be a fraction when we're multiplying by whole numbers, or a mixed number, okay? So we have to start observing that so that we know if we're on the right track, if we're doing the right math. So we observe that 4 goes into 12 evenly, which means our answer has to be a whole number, okay? We know that 4 also represents what? How many groups there are. So if I wanted to model this, let's say I wanted to use fraction circles. I'm going to draw how many fraction circles, how many groups. I'm going to draw 4. These 4 groups are going to equal 12. Okay? So these 4 groups equal 12. Right now, these groups have nothing inside of them. But what would I have to put inside of each group to make them 12? I have to think about what I know about multiplication. And 4 times what equals 12? 4 times 3. So I'm going to put 3 things in here. You could draw stars, smiley faces, whatever you want to draw. I'm going to just do little stars. Okay, so we could relate this back to the M&Ms. If I have 12 M&Ms and I want to take 1/4 of them, well, how many M&Ms is that? Well, I would have to make 4 groups, and I'd have to split them up evenly, or try to split them up evenly. In this case, I can. Therefore, each group has how many pieces in it? 3, okay? Because 3 times 4 equals 12. But I only want one of these groups. This is how many we want or need or have. So we only want one of them. Well, how many is in one of our 4 groups? We have 3. That means that 1/4 of 12 equals 3. We had 1/4 of 12, it equals 3, because we had 4 groups. In those 4 groups, we had 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, but we only wanted one of them, and we know that because of our numerator. Okay, so now us knowing what we know about how if the denominator goes into our whole number evenly, our answer will be a whole number. Whenever our denominator goes in evenly, it's going to be quicker for us to model. And the reason is, I'm going to give you some examples, because then we don't have to do so much converting back into a whole number or a mixed number. Well, in this case, just a whole number. So our problem for this one is going to be 1/4 times 100. This means 1/4 of 100, where we stop and we observe it, just like we do when we add and subtract. So we're observing, observing, observing constantly. Well, what do we observe? We probably observe that that's a unit fraction. Maybe we notice that 4 can go into 100 evenly. And for me to figure that out, I'm using my knowledge that I know about numbers. So if 4 goes into 100 evenly, what that means is that we can model it. So I'm going to model this. Well, my 4, my denominator, represents what? How many groups I'm going to split 100 into? So I'm going to split 100 into 4 groups. This fraction bar right here, this equals 100. So we're going to split this into 4 equal groups. And if you remember and you think about what we had talked about fractions, I want you to do it. We always start in the middle because we're trying to make it as even as we can, so we don't have like a tiny guy here and a big guy right here. So we're going to go we're going to split this into 4 pieces. Now, just like we did up here, we have to stop and we have to think. What number multiplied by 4 equals 100? Well, if I use my money knowledge and I had $1, what kind of money, 4 of them, would go into $1 or 100 cents? Hopefully I'm thinking of the big guys, which is 25. So I'm going to put 25 in each one of these boxes. I'm not going to draw 25 things like I did up here. This is just an example. You're just gonna write the number 25. So up here I could have easily just wrote in 3, but I wanted you to visually see what was happening. So now that we're continuing on, we're just gonna write the number. So 25 plus 25 plus 25 plus 25 equals 100. Do we agree with that? How many of those do I want? Well, where do I look at in my problem to tell me how much I want? I look at my numerator, and we're gonna take how many groups? Hopefully we're all saying 1. Well, in order for us to model this and show, we're gonna cross this off. Well, if I'm taking just one group, how much is that worth? It's worth 25. That means that 1/4 of 100 equals 25. And that is what I modeled. So I could have easily multiplied 100 by 1 and placed it all over 4, but then I would have had to go back and divide. So I'm kind of getting rid of that whole division step, which a lot of 5th graders and people in general struggle with division. So we're kind of skipping that step, but we can only skip it when our denominator goes into our whole number.